Hi, and welcome to lesson 5.7, equation of a line. So by the end of the lesson, you should be able to demonstrate how to determine the equation of a line and graph it. So the biggest thing that we're going to need to be able to do this is this wonderful formula here that you're going to learn to love in this unit, y equals mx plus b. So our y is going to represent our dependent variable. So if we were to, say, draw a set of axes, right, our dependent variable is on the y-axis. Dependent variable. I'm just going to short form, right? We also have m, which we learned in our last lesson is the slope, right? So if we had a line, whoops. Okay, if we have, let me get a different color here. How about this one? So if we have a line, okay, our slope, we learned, is our rise over our run. Right? This is our slope. Okay. Let's see. Red maybe. So the x would represent our independent variable. Right? So this would be our independent variable. I should probably fix this one. There we go. And then our b, this represents the y-intercept. Okay, and the y-intercept is actually where our line touches the y-axis. Okay. Sometimes if we remember from before, we also can call this our initial value. Okay, so this little equation tells us a lot about a line, and it becomes really important in this unit when we're graphing. So if we take a look at some of these equations, we're going to want to state the slope and the y-intercept for each of them. So in this first one, we have y equals 4x plus 1. So remember this part, right? It's y equals mx plus b. M is our slope. So in this case, our slope would be 4. And our y-intercept is just b, which is 1. For this part B here, y equals negative 5x, so our slope would be negative 5, and our y-intercept, well, we don't have plus anything, but it's really plus 0, so our y-intercept is 0. And then the last one here, y equals 3x over 2 plus 5, our slope would be 3 over 2. Please do not write the x. The x is not part of the slope, right? Just the numbers. And then our y-intercept is b, which is our 5. Okay. So next we want to be able to write the equation of a line if we're given some information. So here they gave us the slope is 3 over 5 and our y-intercept is negative 2. Well, we know it's y equals mx plus b, so we're just going to sub in the values they gave us. So they said that m was 3 over 5, keep the x, plus negative 2. So instead of writing plus negative 2, we could just put minus 2. In this next one, they gave us the rise and the run. So we know that slope is rise over run, which means that we have a slope of 6 over 7. So if we plug that into our y equals mx plus b, we're going to have 6 over 7x, and then the y-intercept is 8, so plus 8. Okay, for these ones, you need to make sure that you write the y. It's part of the equation. All right, and then the last one here, they gave us the slope is -2 and the y-intercept is 9. Okay, so just subbing in values. Okay, so next we're going to try and determine the equation from the line using a graph. So they gave us 2 points on our graph, and we could also figure out the slope. So we can figure out the slope one of 2 ways. One way that we can do it is by just using rise over run. The other way, oh boy, there we go. The other way is by using our formula that we talked about yesterday. So we're going to do both just to confirm that we're right. So first off, we can just get our slope from our graph. That's kind of the easier way. So let's draw some arrows here, figure out what our rise and our run is. So slope is rise over run. Well, our rise, it went up 1, 2, 3, and our run was 1, 2, 3, 4, 5, 6. So if we reduce, we have a half. And then our y-intercept, okay, our y-intercept here is we're looking for where our line crosses the y-axis. So it would right here. So this is our B, and our y-intercept would be -3. So using this information that we have, we could write our equation as y equals 1/2 x minus 3. So like I said, we're just going to check our slope just to make sure that we did it properly using our equation. So y2 minus y1 over x2 minus x1. Now it doesn't matter which one is your 1s and 2s. So this could be x1, y1, and this could be x2 and y2. So y2 would be -1, y1 minus -4, and x2 is 4 minus -2. So what have we got? -1 plus 4 is 3, and 4 plus 2 is 6. So it's the same. Okay, so you can do it either way. It doesn't matter, whichever way you're more comfortable with. Right, so we're going to try this next one. We'll do the same idea. I'm going to draw my rise and my run. So rise over run. Well, my rise was pointing down. 1, 2, 3, 4, 5, 6. So we went down 6, and then we went 1, 2, 3 to the right. So -6 over 3 is -2. So that's my slope. And now my y-intercept, check where it crosses the y-axis, right here, right? So it's 6. So therefore, my equation of the line is y equals -2x plus 6. Okay? And we could check using our points, but to save some time, we're not going to. Okay. So some success criteria, if you're graphing a line, given the slope and the y-intercept, we always want to first plot the y-intercept. That's the most important part. Start with the point you know. Then we're going to use the slope to determine the rise and the run. And then last, from our y-intercept, we're going to rise up and then run over the number of units that we found from step 2. So we're going to try and do this using our success criteria. All right, so we want to graph the following lines. Before we graph them, we're going to write down what we know about each line. So for our first one, we have y equals 3x plus 2. So our y-intercept, right, this is, remember, it's y equals mx plus b. B is our y-intercept, so it is 2. And if we need to write it as a point, right, x is always going to be 0 for a y-intercept because it's where it crosses the y-axis. And in this case, y is 2. Our slope, right, that's our m, is 3, which means that our rise is 3 and our run is 1. Because what's underneath the number if we don't see anything? Always a 1. Okay. So now that we have this information, we could try and graph this. So our y-intercept is 2, so we're going to go ahead. Remember, we're going to start by graphing our y-intercept, so plotting that point at y equals 2. And then we're going to use our rise and our run to get a second point. So it says that we're supposed to rise up 3. So from our y-intercept, we're going to go up 1, 2, 3, and then over 1. And then I'm going to draw a dot there. Now to draw a good line, we should have at least 3 points. So I'm going to do the exact same thing again. From the dot I just drew, because my slope should be the same, I'm going to go up 1, 2, 3 again, and over 1. And I'm going to draw another dot, just to make this a really good line. And then I'm going to connect all 3 dots using a ruler. Again, I am using a ruler, but the screen makes it shaky. And the last thing that we should do is label our line. So this is y equals 3x plus 2. Okay, so let's try this again for the next question. So now, our equation 2 is y equals negative 4 over 3x plus 2. And it wants us to say a negative signs always go with the top number. Okay? So our y-intercept here, again, is 2. Our slope is negative 4 over 3. Remember, rise, the negative goes with the rise, the run is 3. So let's try to graph this. Well, our y-intercept is 2, so start with that, put a dot where y equals 2, right? It's still the point 0, 2. And now we have this slope of negative 4 over 3. So our rise is negative 4, which means from our y-intercept, we're going to go down 4 spots. So 1, 2, 3, 4. And then our run is always to the right. So our run, we're going 1, 2, 3 spots over. And that's where we're going to draw our dot. Okay, and then like I said, for any graph to be really good, we want 3 dots. So from the one we just drew, we're going to go down another 1, 2, 3, 4, and over 1, 2, 3 to get a third dot. And then use our ruler and draw our line. Okay, always extend past your dots and label. Okay. So we have one more way that we're going to look at today, some horizontal and vertical lines. So we saw those in the first lesson and saw that they were a little bit special. So we're going to take a closer look at these. So we want to create a table of values and a graph for the following equations. So the first one is just y equals 3. So I'm just going to pick some values for x, negative 10, negative 5, 0, 5, and 10, just to spread it out. So when x equals negative 10, if we look at our equation, there is no x to plug in, y equals 3. Y always equals 3. So if we were to plot our points here, when x is negative 10, y is 3. When x is negative 5, y is 3. When x is 0, y is 3. When x is 5, y is 3. And when x is 10, y is 3. So if you notice, when we have an equation that says y equals, and then just a number, we get a horizontal line. Now, if we take a look at the second one, we have x equals negative 8. So in this case, x is always going to be negative 8 because we have no y value. We can make up whatever y values we want. So, I don't know, 3, let's do, wait a second. What if we do, I'll do the same, negative 10, negative 5, 0, 5, and 10, because it can fit. So when x is negative 8, need this. All right, x is negative 8, when y is 10, when y is 5, when y is 0, when y is -5, and when y is -10. So you can see this one made us a vertical line. So this is x equals 3. So if we take a look here and answer some questions here. So for our first one, where our equation was y equals 3, our y-intercept is 3, but our slope is 0. Okay? So we would be actually writing y equals 0x plus 3. Right? That's one way to write this. Why don't we write the x? Well, 0 times anything is 0. So it's kind of unnecessary in the equation. Okay? So we could say 0 multiplied by x equals 0. Right? That's why we don't write it. Now, if we look at the next one, x equals 3, a y-intercept, well, if we look at our graph, it never touches the y-axis. So we don't have a y-intercept. It doesn't exist. And our slope, well, we know we have a run of 0. So we can rise up as high as we want, but our run is 0. So anything divided by 0 is undefined. So one way to remember these, so whenever we have y equals a number, right, this is telling us that we have a horizontal line. Right, it's telling us a horizontal line with a y-intercept. If we ever just have x equals a number, this is a vertical line with an x-intercept. So an x-intercept would just be where the line crosses the x-axis, right? We have no y-intercept. Okay, so that's the end of this lesson. Make sure that you practice drawing some graphs from an equation and then write an equation from a graph. And let me know if you have